Start. So, good evening, everyone. Welcome to IIT and Gate classes. This is the exclusive Gate coaching by the IIT and ISC graduates. And let me introduce myself before starting the session. So, guys, this is Saket Verma. I am having more than 13 years of experience in the field of Gate and ESC. So, I've been teaching more than 13 years in the Gate and ESC aspirants only. And I have done my MTech from IIT Guwahati in signal processing in 2010. And my achievements are I have all along with the gate I cracked the Airport Authority of India in 2010 only, DRDO in 2008, and Bharat Electronics Limited in 2014. Since then, I am still mentoring the students in the field of gate because I enjoy teaching, and I become very happy when my students get success in the gate examination in their career. So apart from the gate examination, also you if you want any guidance, you can connect with us. And these are my area of expertise. I may be dealing with electromagnetic theory, communication system, advanced communication system, and signal system with you. And so today's topic is a kind of a demo session where you will understand that how the communication system actually are, means what are the weightages, what are the syllabus that we are going to cover in the communication system. And along with that, you will also able to solve one of the question from the gate 2024 itself. After attending this session, one questions you will be able to solve from the gate 2024. That will give you the confidence that if you prepare with us, we are going to guide you in such a way that you will be able to solve the gate questions also immediately right after attending the single lecture only. You will be able to do that. And guys, the overall syllabus of the communication system, it is there for electronics student and for instrumentation student. Some portion of the electronics syllabus is common with the instrumentation syllabus, and some portion is also common with the electrical ESC syllabus. So I will be telling you some chapters, uh, not exactly the each topic mentioned in the syllabus of gate. The official gate syllabus you can download from anywhere, means ISC portal you can download for sure. So here I will be telling you some chapters. Okay, so in the communication system of EC, okay, this is the communication system syllabus for gate EC. So gate EC, we will have two, actually we can say the three parts. First is analog communication, okay, and then we will say the digital communication, and then you can write random variable and random process. Okay, so in this way we will divide it. The overall syllabus of digital communication, within the 5 minutes I will quickly go through all the topics of the syllabus. So analog communication, digital communication, and random variable and random process. When you will see this overall in your GATE official syllabus, so it may be in the form of random process only, but obviously without understanding of the random variable, it is not possible to understand the random process. So we are keeping these three chapters. Okay, the in the analog communication, you will have three different chapters. First is your amplitude modulation. And second is your angle modulation. Keep on commenting if you have anything in your mind, okay, because you are starting your gate journey. So if whatever is coming in your mind, you can keep asking us. So that will be a very interactive session actually. Okay. And it would be helpful for you to understand that how to plan your next 1 year to crack gate with the top rank. So I will suggest you to keep asking. If anything comes in your mind, then don't be don't hesitate and just put in the comment section only. Now we have digital communication with us. So there are 4 chapters in the digital communication. Okay, and first is known as baseband transmission, and second is known as band pass transmission, and third is your noise in digital communication. Noise comes under the digital communication only. In analog communication, the noise is there, but it is not in our gate syllabus. Noise is present everywhere, whether you perform analog or you perform the digital. In both places, the noise is there. So we will have the noise only in the digital communication. So baseband transmission, bandpass transmission, noise in digital communication, and information theory. Information theory and coding. And the random variable random process itself is a single chapter, so there may be a multiple topics there. So the topics name I'm not writing. These are the number of chapters we have to discuss. So if you will see, so we are going to discuss around 1 2 3 4 5 6 7 and 8 9. So total of 9 chapters. Okay, total of 9 chapters are there. Okay, this is the first chapter, second chapter, third chapter, fourth, fifth, sixth, seventh, and random variable is in one chapter 8, and ninth is the random process. And 10th you can also, okay, 10th we have already written here in the form of coding. So coding can be a separate chapter you can make. So the 10th chapter may be a coding. Now, this is the syllabus of GATE, EC. Now, if I talk about the instrumentation syllabus, so for the instrumentation student, only this portion they have to cover. That is the syllabus of GATE IN. Okay, if you are suppose writing the GATE from the IN, because now you know that there are 2 branches allowed. So if you are planning for MTech, then you can go for the instrumentation also, because the BTech from EC, and but the gate score instrumentation you can take admission from MTech, because there is a less competition in instrumentation. Okay, and the chance of getting very top rank is more in gate IN if you prepare. But there are many other chapters also that you need to prepare. So you should be ready for that, because in the syllabus of the instrumentation, they have put the syllabus of a little bit of electrical also. So there are a lot of subjects, or there are many subjects that you have to cover. So it is not suggested if you are from EC. So first you just go for EC first, means you complete the EC syllabus first, and then if you are confident enough that you are able to solve the questions of the gate EC, then you can go for some extra subject of instrumentation. But first you have to cover these EC syllabus, and then you should go for instrumentation. Obviously you should take advantage of the second paper also, but not compromising with the first paper. Your basic paper should be very strong, then go for the second paper. So gate IN has the syllabus in this first and second chapter, and here third and fourth and fifth chapter. So these all 4 chapters are there in the gate IN. Okay, and if I talk about the electrical EAC, if you suppose planning for the EAC also, so electrical EAC, let me write here, electrical EAC. Chapter number 1, chapter number 2, chapter number 3, 4, 5, and 7. Only these chapters you have to cover if you are planning for ESE. Okay, electrical ESE students can also cover this particular part if you are planning for ESE. Okay, so this is the complete syllabus, and the weightage of this subject for ESE is around not ESE, EC is around 10 to 12 marks. Okay, 10 to 12 marks for EC. For IN, it covers around 4 to 5 marks. Okay, for IN it is 4 to 5 marks, and electrical ESE we cannot comment because ESE will have many questions, more than 10 questions from the communication can be asked. So number distribution can be different. So you can say number of, in terms of number of question, it is more than 10 to 10 questions. Okay, so this is the overall syllabus. Is it clear to everybody?
Yes,
Rashid?
sir.
Yes, clear, right? Okay, good. Now we move forward. Yeah. This is our first demo session, so we are going to understand before going into the deep or inside the amplitude modulation. We are first understanding what is modulation. Okay, so what do you mean by modulation? How we do perform the modulation, that we have to understand. So modulation is the process in which characteristics of one waveform, that is carrier wave, varies in accordance with the characteristics of another waveform, that is modulating signal. So whenever you perform the modulation, there must be a two signal. So okay, so there must be two signal, and one signal is called carrier signal, another signal is called modulating signal. So one signal is called carrier signal, another signal is called modulating signal. So basically, the carrier signals are fixed signals. That are fixed signals. Fixed signals, that means it is a sinusoidal signal, mostly sinusoidal. Okay, we take mostly sinusoidal signal. Okay, fixed signal means mostly sinusoidal we will take, and every sinusoidal signal can be represented in terms of its amplitude and their frequency and the phase. Okay, so in this way, we are saying that the characteristic, that is amplitude, frequency, and phase. So these three things are fixed for any sinusoidal signal. Okay, so for any sinusoidal signal, these three parameters are same. So we have to change these three parameters according to our message signal. What are the message signals? Message signals can be voice signal, the way I am talking to you, so that is my voice. So my voice or speech signals are same. Similarly, it can be the video signal. Okay, it can be the audio signal. So these are the message signals we generally see in our day-to-day life. So these message signals will change the characteristics of this fixed signal, which is a carrier signal. And what are the characteristics which you change? The characteristics would be am, omega m, and phi. So these three parameters will be changing according to the message signal or modulating signal, is called the modulation. Okay, so in modulation we will have two signals every time. Whenever you want to perform the modulation, you should have the two signals. One signal will have fixed characteristics, which are known as carrier, and another will have a message signal which can be variable, because message signal can be your message signal can be your text message, it can be your voice message, it can be your video signal, it can be your audio signal. So the message signal will keep on changing, but the carrier signal will not change. That means, now the second thing, that what is the need of this carrier? Okay, it can be understand by one analogy, very basic analogy. If you suppose throw a piece of paper, okay, if you throw a piece of paper directly, then if suppose you wrap up the piece of paper and then you are throwing, so the piece of paper can be considered as your information signal. Okay, so you are throwing that information you are writing something on paper and you are throwing that information, okay, to somebody, and it may not travel the long distance because uh, when you throw it, a piece of paper cannot travel so far. But when you wrap this piece of paper to a stone, okay, and then you throw it, then that, with the same force, that stone will travel longer distance, right? So what is the stone doing here? The purpose of a stone is to carry that piece of paper for a longer distance. So that means we are using the carrier to carry our information for a longer distance. Okay, so that is why the name is given as carrier, because it is carrying the information to a longer distance. So now you can throw a piece of paper wrapping on the stone, then it will travel a longer distance with the same force which you were putting before wrapping the paper on the stone. Correct? So this is how you can understand the meaning of modulating signal and the carrier signal. A single piece of paper is your modulating signal, which will carry the information, but it cannot travel the long distance if you transmit it directly. But if you if you use the carrier signal to carry your information signal, then it can travel to the long distance. So the distance or the range can be increased by modulation. That is the first important point to note, that when we perform the modulation, it increases the range of communication. Okay. Now, there can be another alternative definition of modulation. Modulation translates a low frequency signal to the high frequency signal. Modulation translates the low frequency signal to the high frequency signal. So whenever you perform the modulation, it converts your low frequency signal into high frequency signal. That is known as frequency translation. And when you perform the modulation, this also converts your low pass signal into band pass signal. So in this way, it converts the low pass signal into band pass signal. So these are the different ways to define the modulation. Now you have understood the basic definition. Now important point is, how do you perform it? We have said it in words that these are the modulation, and this is actually carrying the information for a longer distance, that we understood by analogy. And we are saying that it is also converting low frequency into high frequency. But how? What is the proof? How will you prove it mathematically, right? So now to prove it, we will use uh, this particular block diagram. Now we have a modulating signal. As I said, that this modulating signal will be having the low frequency. All the message signals are having the low frequency. For example, if I talk about the voice signal, okay, if I talk about the voice signal, then our voice will have the range around maximum up to 3400 hertz. So any person voice will not beyond this 3400 hertz. Similarly, which signal we can listen will have the audio signal, right? So what is audibility? We can listen, that is 20 hertz to 20 kilohertz. So all these signals are considered as a low frequency signal. So these are considered as a low frequency signal. We want to convert this low frequency signal into high frequency signal. Okay, so we want to convert it. How do we convert it? To convert it, we are using a carrier signal, which is our sinusoidal signal, and whose mathematical expression will be, because the word we have understood that it is going to carry our information, so we use AC cos omega ct. That is the carrier amplitude cos omega ct. And let us say our information message signal is mt, m for message, so mt is mostly used, and this is the carrier, and the modulator just performs the multiplication. Okay, right now for us, because we have not dive into the deep concept of communication, so right now we are not going for the what is the exact meaning of modulator. The Just think of like modulator is a block which perform the modulation. Okay, modulator is a block which perform the modulation, and mathematically it is actually going to multiply the signals which are coming in the input. So in this block, what are the input? Input is carrier signal and another input is message signal. And I told you that it is going to multiply the signals which are coming in the input. So message and the carrier is input. So what will be our output? Our output will be mt into AC cos omega ct. So this is our output. Okay, now have written here, you can see that the message signals are low frequency, that we can understand directly from the real life example. These are in hertz and few kilohertz, so these are considered as a low frequency. But carrier frequency I have written high frequency, and in the output also I have written high frequency, because I told you that the modulation is the process in which the low frequency is converted into high frequency. That means the frequency translation is happening. So the low frequency is converting into high frequency, right? And for that we are multiplying with high frequency. Now again the question comes in our mind, that the proof. So the y of t is mt into cos omega ct multiplied with AC also. AC is also there. Now let's take the Fourier transform. Let's take the Fourier transform. Right now you may not be knowing about the Fourier transform, but once you go and cover all the part of the syllabus, like signals and controls and all, then you will automatically know. So right now I am assuming you know it. If you don't know, just uh, write in this way: AC by 2, the whatever will be the amplitude gets half, and the Fourier transform of message will be shifted to the frequency of carrier, m of f minus fc and m of f plus fc. This is we understood in the last class actually. The demo session of the signals, we discussed about this shifting, the that means the delay and the advance. But okay, for now it is just understandable that it is the message, this is the output, and when we take the Fourier transform we get something like this. Okay, now how do you draw this m of f minus fc and m of f plus fc? Suppose we have a message signal. Okay, suppose we have a message signal. Okay, this is the shape. All these things you will better understand when once you cover the signal. So whenever you we will start the complete syllabus, full syllabus. This is a demo session, so when we start the full syllabus I will definitely cover the all the basic things required before the communication. Okay, so don't worry about that. Just right now let's assume that we have a triangular signal which is having the highest value fm. Okay, this is our message signal which have the shape like a triangular signal and having the maximum frequency fm and the minimum frequency up to minus fm. Okay, and what we have written here, the amplitude gets half, and m of f, that means this is your m of f. It is m of f minus fc and m of f plus fc. So how do you draw m of f minus fc and m of f plus fc? Okay, so the m of f minus fc means shifted towards right. When you perform m of f minus fc, it actually shifts towards right. So minus sign means it shifts towards right. Okay, so 0 will shift. 0 will shift to fc. So what is the distance from 0 to the maximum value? Fm. So it will be Fc plus Fm. Or in simple words, you can say if you want to shift the signal towards right, you have to add Fc in all the x's. Okay, because here you can see F minus Fc equal to 0. So F equal to Fc. So add this Fc in all the x's. Okay, so when I add it, 0 plus fc will become fc. So this peak value which was previously at 0, now at fc. Now this value which was 0 at fm, now when you add them it will become fc plus fm. So this is fc plus fm. When you add these two it will become fc minus fm. So it is fc minus fm. So in this way we shift the signal towards right. Now similarly, the similar way you can write m of f plus fc. M of f plus fc means you will add minus fc to whole axis, because f plus fc equal to 0, so f equal to minus fc. So this minus fc should be added. So now you add minus fc in the whole axis. Okay, so minus fc minus fc minus fc. So when you add it, it will become minus fc minus fm. 0 minus fc is minus fc. Why this is minus fc plus fm. So now it is shifted somewhere here. Okay, so it is minus fc. This is minus fc plus fm, and this is minus fc minus fm. So in this way we will get the signal. Okay, now what we have done in this equation, these two terms we have got, these two terms are added. These two terms are added and the amplitude is AC by 2. Okay, so these two terms when you add, addition means you have to draw both the term in the single plot. So you have to draw AC divided by 2 in bracket m of f minus fc plus m of f plus fc. Okay, now when you add it, the left hand side is this one and the right hand side is this one, and the amplitude will become AC upon 2. Previously the amplitude was 1, this amplitude was 1, now it is AC by 2 because you have multiplied by AC by 2. So this is your FC, this is my FC plus FM, and this is FC minus FM, and it is minus FC and minus FC plus FM and minus FC minus FM. Okay, now this is our signal. Now the question is how we are calling this as a high frequency signal, right? Because we have got that this is a low frequency. Which one? This is. This is a low frequency. Okay, because it is our message signal. Now how it is high frequency? So this is low frequency. So let us say FM is equal to 5 kilohertz, right? And now according to this block diagram, the low frequency we have to take. So I have taken 5 kilohertz. Now we have to take high frequency. So let us take high frequency as 1000 kilohertz. Okay, very, very high frequency. FC should always be very, very higher than FM. Then only the modulation will be better. So FC, when you choose FC, it should be always very, very high. So if it is 5, so it is very, very high, 200 times. Okay, so FC is very, very greater than FM. So this value will become 1000. Okay, this value will become 1000 and this will become 1000 plus 5. Okay, and this will become 995. So from here you can see that this is the 1005 kilohertz. So 1005 kilohertz is definitely very, very high value. Okay, these all are in kilohertz. Na? These all are in kilohertz. So this value is 1005. So previously our message signal was 5 kilohertz. Now after modulation, the maximum signal frequency is FC plus FM, which is 1005. So previously the message signal will have maximum value up to 5. After modulation it is 1005. So now we can say that we have converted our low frequency into high frequency. We have converted our low frequency into high frequency. Clear? Is it clear through the diagram? The low
Yes, sir.
frequency
Yes, sir.
shifted to high frequency. Now, what are the advantages of doing this? Okay, we have performed the modulation. So what are the advantages of doing this? So need of modulation. Why we perform the modulation? First, I told you that it increases the range of communication. So the modulation increases the range of communication because a single piece of paper cannot travel the long distance, but when you wrap it with the carrier, when you when your information is carried by the carrier, then the information travels the longer distance. So the range automatically gets increased. Now the first point here written is modulation reduces the height of antenna. Okay, so how we are saying this height of antenna is reduced, that can be understand by the taking one example, height of half wavelength antenna. Height of half wave dipole antenna. Okay, what is the height of dipole antenna? Height of half wave dipole antenna, that is given by lambda by 2. So when we study the electromagnetic theory, there you will understand. So the height of half wave dipole antenna is lambda by 2. Lambda is what? Wavelength of the signal to be transmitted. So how do you calculate the wavelength? Wavelength is nothing but the velocity of light divided by frequency. So lambda is equal to c by f, and there is already 2. Okay, so now when you take the frequency of information as suppose 3 kilohertz, just for example 3 kilohertz, then what will be the height of antenna? So height of antenna is 3 into 10 to the power 8 divided by 2 into 3 into 10 raised to power 3. Okay, so how much it is? This 3 and 3 will get cancelled, and this is 10 raised to power 5 divided by 2. So it can be 100 upon 2 kilometer. That means 50 kilometer. Correct? So 50-kilometer antenna you have to install in your at in your place. Maybe it may be in the roof of your house to transmit a 3 kilohertz signal. So can you imagine 50-kilometer antenna? Not possible. Okay, not possible to install. So it is practically not feasible. Practically not feasible. Theoretically we can say, but it is practically not feasible. So now what is the solution? The solution can be, we have to reduce the height of antenna. How can you reduce the height of antenna from this equation? You can easily say that, sir, if I increase the frequency, then the height of antenna will reduce, because velocity of light we cannot reduce. So obviously the frequency we have to increase. So what will happen after modulation? That you have understood from that graphical analysis, that after modulation what happens? After modulation the frequency increased. So let us say the frequency increased to the 10,000 kilohertz, let us say. Okay, somehow you have converted into 10,000 kilohertz. Now what will be the height? L is equal to c upon 2f. 2 into 10,000 kilohertz means 10 raised to power 7. Okay, 10 is power 7. So how much it is? 30 upon 2, that is 15 only. So 15-meter antenna is still possible, right? 15-meter antenna to transmit our information is possible. So in this way you can understand that modulation reduces the height of antenna. So how this is reducing the height of antenna, now you have understood. Okay, now the third is also modulation allows the multiplexing of the signal. So that multiplexing of the signal means it is not mixing the signal. What happened in the previous days, old days, when the amplitude modulation was discovered, our voice signal in the telephone exchange, we all have the same voice signal range, right? uh, any human being will have the voice range from the 300 hertz to 3400 hertz. So that is why we have written here speech signal. So that speech signals will have the range of 300 to 3400. So that is valid for all the human beings. So now if I say in the anything in the telephone, and you are also transmitting your information in the same range because our voices are same, goes into the telephone exchange, all will have the same frequency range. And what the telephone exchange does, they mix the signals and then they transmit. So once our signals are mixed, it is difficult for the receiver to isolate them. Okay, so let me tell you with this diagram. Suppose you have one in, we both are transmitting the signal because we have one channel only. The channel by which we want to transmit is a single channel. Okay, so here you first person and here is the second person. Both want to transmit their data. So they transmit their data. So to transmit here, this channel will take only one input. This channel is capable of taking one input. So what we have to do, we have to add our signal because the two different signals this channel will not allow. So this channel is not allowing the two different signals. So what we are doing, we are combining our messages and then we will transmit it because only one signal can be transmitted through the channel at a time. So what we do, we perform the addition of the signal. So when you perform the addition, so suppose this is your rectangular signal and this is our triangular signal. These two signals are mixed and it generates, suppose, some random signals like this. It is generating some random signal like this. Okay, when you add this message signal and this message signal, I'm taking just random shape. Okay, so this is our mixed signal. Now when it reaches to the receiver, we want to separate it because you don't want my message signal to be transmitted to the second user, and I also don't want my message signal should be transmitted to the first user. Okay, we don't want to when you are talking in the telephone, you don't want your information to go to the other person, right? So we both are transmitting our information individually, and we want that this first user want that the his information should be transmitted to the first user at the receiver, and this second user want that his information should be transmitted to the second user. But when these signals are combined, these analog signals are not easy to distinguish. We cannot separate them from this signal. We cannot separate them. We cannot say that it is a triangular and it is a rectangular, and then this rectangular signal should be transmitted to the first user and this triangular signal should be transmitted to the second user. We cannot distinguish by looking into this graph. By looking into this graph, we cannot distinguish between the triangular and the rectangular signal. So that's why it is mixed. Actually this has mixed the signal. Okay, this has mixed the signal. Now what we do, what we can do to that so that the receiver will be able to distinguish the signal. So to make it distinguishable, what we do is we will multiply it with some carrier frequency. Okay, before adding these two, we have to add, still we have to add because the channel is one only. The channel is only one. So we have to add them. But when we add directly, it is not possible to distinguish the signals. But when we multiply with the carrier, and the carrier frequency is different for both, the carrier frequency is different for both. Okay, now this message signal has the Fourier transform M1F, and now suppose this has been shifted to F1. You know that how it is shifting, right? That we have already understood in the previous example, that how to shift it. Whatever shape is there for the message signal, when you multiply with the frequency FC, it shift to FC. So similarly, whatever is the shape of our message signal, when I multiply with F1, this will shift to F1. When I multiply with F2, this will shift to F2. Okay, so this is the spectrum of the first user and the second user, and now these two are added. Now these two are added. So when you add them, this signal will become F1 and F2 are well separated. Okay, F1 and F2 both are different. So this F2 will shift the signal here, and this F1 will shift the first signal here. So this is our first signal, this is our second signal. Okay, this is our first signal and this is our second signal, and when these two are added, f1 f2 is greater than f1. So f1 f2 are well separated, so these two are separated. Now when it reaches to the receiver, what receiver will do? Receiver will keep filter here. Receiver will keep filter here, and with this filter, the first user will take his data, which is this signal, and the second user will take his data, which is this signal. So because this is a filter, it can separate these two signals because these two signals are distinguishable. One is a rectangular signal, another is a triangular signal, so both the signals are distinguishable. So that is why we can keep filter. Even if I keep filter here, I will not be able to distinguish in the first case. If I don't perform the modulation, this both have mixed in the time domain or in the frequency domain, so it is difficult to distinguish even if I use the filter. But when I modulate it before adding, then it is possible to make the signal distinguishable, and it can be distinguished in the receiver with the help of filter. Clear? Are you understanding? Actually, there are a lot of mathematics behind that. I can tell you that in the full course, but right now, to make you understand the statement that we are saying, it allows the multiplexing of the signal. So multiplexing means there should be many signals and it can be combined to a single, many to one. Multiplexing means we should have multiple signals and it can be transmitted through a single channel. So we have two message signals, 1 and 2, and these two are transmitted through a single channel. So that is actually a multiplexing. Clear? Now, coming to the amplitude modulation. So when you change the amplitude of the carrier. Okay, amplitude modulation is the process in which the amplitude of the carrier wave, when you change the amplitude of the carrier in accordance with the instantaneous amplitude of modulating signal. Instantaneous amplitude of modulating signal. That means according to your message signal, modulating signal is nothing but the another name of message signal. So when you change the amplitude of your message signal, when you change the amplitude of carrier signal according to the amplitude of message signal, then it is called amplitude modulation. So the definition of modulation is same. The one definition we have understood, that it is frequency translation. Okay, modulation is the method in which we transform the low frequency signal into high frequency. That means we are performing the frequency modulation. Correct? We are performing the frequency translation. Now, one more definition that we have seen, this definition we have understood by graphical method. Now, this definition also we have understood, but now there were three parameters: amplitude, frequency, and phase. Now I am changing this amplitude of what? Carrier. Amplitude of carrier I am changing according to the message signal. According to the message signal. Then it is called amplitude modulation. So any amplitude modulated signal can be represented mathematically by this equation. How this equation is generated, that comes under the subsequent topic of amplitude modulation. But everywhere, in any textbook also, in NPTEL also, wherever you see, always we start the understanding of amplitude modulation by this expression. We directly assume that the amplitude modulated signal is given by this expression. That is truth. Now we have to understand what are the parameters associated with this equation. So first, AC. AC means carrier amplitude. What do you mean by AC? So the carrier which we are using, that carrier amplitude is AC. Now what is Ka? K is amplitude sensitivity of modulator whose unit is volt inverse. This is a constant value. FC, here you can see the cos 2 pi FC. FC is carrier frequency. What is MT? MT is your message signal by which the amplitude of carrier is changing, modulating signal or message signal. Okay. Now, the next parameter which is associated with this is modulation index. So because we are performing the modulation, so up to which depth we are performing the modulation, we calculate by the modulation index. So modulation index or depth of modulation or modulation factor, these are the different nomenclature which we use for modulation index. So modulation index or depth of modulation is a measure of extent to which modulating signal modulates the carrier signal. Okay, we are suppose mixing the two different liquid, so liquid A and liquid B. So how much liquid A is mixed with the liquid B, right? So how much you are mixing liquid A, how much you are mixing liquid A with B, so that is measured by the modulation index. That we have a carrier signal. Okay, we have a carrier signal that was having the fixed property, it was having the fixed amplitude, it was having the fixed frequency, having the fixed phase, AC cos omega ct. Now we are bringing our message signal to change its parameter. And which parameter we are changing? Only amplitude we are changing. We are keeping the frequency and phase constant. So we are mixing our message signal with the carrier signal to make change of the amplitude of carrier. We are mixing our message signal, and this mixing will change the amplitude of message carrier signal. This mixing will change the amplitude of carrier signal. So how much it is changing, up to which extent you are mixing your message signal with the carrier signal is called modulation index. Okay, now let us say our message signal is also sinusoidal. Let us say our message signal is also sinusoidal. What do you mean by the sinusoidal? Sinusoidal means AM cos omega mt, and single tone means only one frequency component. Single tone means only one frequency present in the message. Only one frequency component. Only one frequency component is present. Okay, single tone means only one frequency, and sinusoidal means cos omega mt. Now, modulation index is defined as the K, that is amplitude sensitivity, and maximum value of mt. So what is the maximum value of your message? Because the cosine is having the maximum value 1, the maximum amplitude is am. Maximum amplitude is am. So what is the modulation index? Modulation index will become K into am. So this is one formula you are getting. Very important formula to solve the gate question. Modulation index is equal to K into am. How do you get this K? Whenever the equation is given, you compare the equation with this standard formula. On comparing, the coefficient of message signal will become Ka. On comparing, the coefficient of message will give you the Ka, and whatever message signal is given, the maximum amplitude of message signal multiplied with the amplitude sensitivity gives you the modulation index. It is a dimensionless quantity. Modulation index is a dimensionless quantity. Okay, so this is how we define the modulation. Now we will substitute that. We will substitute the single tone value. Okay, we will substitute that message signal. We will substitute our message signal in this equation. Okay, so AC 1 plus MA. How this is MA? Let me write over here. Okay, let's substitute in this place. Our standard expression of amplitude modulation is AC cos AC in bracket 1 plus K into MT cos omega ct. Now we will put our message signal, which is am cos omega mt into cos omega ct. So k into am is modulation index. In the equation We can see this is the modulation index. So this is AC 1 plus MA cos omega MT into cos omega CT. Okay, so this is how this equations we are getting. AC 1 plus MA cos omega MT into cos omega CT. Now we will multiply this. So cos omega CT is multiplied here. AC cos omega CT, and here it is AC MA cos omega CT and cos omega MT. So here this is the multiplication of 2 cos. So we know the formula of 2 cos A cos B. What is the formula? That is cos A plus B plus cos A minus B. Right? So this is, we are performing here cos A plus B. Always FC is always greater. FC should always be greater. So that is why A I am writing first as a FC. FC plus FM and FC minus FM. Always subtract higher value, higher minus lower. Okay, so higher value is FC. So FC minus FM and FC plus FM. Okay, so that is your carrier signal. Okay, and this is carrier signal. So now when you break it in the three different parts, cos A plus B and cos A minus B. So this is our first term, this is our second term, this is our third term. So we are getting three different terms. Okay, so this is the carrier frequency, or you can also call it as a center frequency, because it will come in the middle. Frequency component less than carrier. Frequency component less than carrier. Okay, the term which is having frequency less than carrier is known as lower sideband. Okay, that is known as lower sideband. Okay, now this is frequency component because it is more than carrier, because you are adding something. So when you are adding something means frequency component higher, because you are adding something. So frequency component higher than carrier. The frequency component higher than carrier is upper sideband, because you are going upper side. When you add something, you are going towards upper side. So it is upper sideband. Okay. So now these three different terms are clear. Is it clear to all of you? When you talk about amplitude modulation, whenever you talk about amplitude modulation, it is basically two sideband, double sideband, double sideband, full carrier, double sideband, full carrier. That is known as DSBFC. 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 Double sideband. How we are getting two sidebands? Is it clear to all of you? When you put your message signal in the expression of amplitude modulation, you will get the three terms. One is the same carrier frequency which you use before modulation for multiplication purpose, and the two extra term will come, which is having the frequency higher than carrier and lower than carrier. The term which is less than the carrier is lower sideband. The term which is higher than the carrier is called upper sideband. Clear? Right? Now, just tell me one thing. What is the power of any cosine signal? What is the power of any cosine signal? I think this everybody can tell. What is the power of any cosine signal? How do you write it? How do you write the power of this? Power of any cosine. Power of any cosine signal. Come on. Guys, can you comment? Power of any cosine wave. It is nothing but the amplitude square divided by 2. Am I right? Amplitude square divided by 2. For any cosine wave, the power is given as amplitude square divided by 2. Now, on the basis of this, we are going to write the power of each term. Okay, we have calculated the three different term. All the term are having cosine. Irrespective of their frequency, the power is only amplitude square divided by 2. So if I calculate the carrier power, which I represent it as a PC as a carrier power. So carrier power is amplitude square divided by 2, that is AC square by 2. What is the power of sideband? Let us say upper sideband. What is the power of upper sideband? Upper sideband is having amplitude MAAC by 2. So amplitude is MAAC divided by 2. So amplitude whole square divided by 2. So we will get MA square AC square divided by 8. What is the power of lower sideband? The power of lower sideband is also same because the amplitude of lower sideband and upper sideband was same, MAAC by 2. MAAC by 2. So we will put MAAC by 2 whole square divided by 2, MA square AC square by 8. Okay, if I ask you to calculate the total sideband power, total sideband power. If I ask you to calculate total sideband power, what you should do? You have to add the power of upper sideband and lower sideband. So when you add the power of upper sideband and lower sideband, you will get MA square AC by 4. Okay. Now if I ask you to calculate the total power in amplitude modulation, so total power in amplitude modulation. So because in amplitude modulation, we transmitted carrier and sideband, we have to add both the power. AC square divided by 2 plus MA square AC square divided by 4. Okay, AC square by 2 plus MA square AC square by 4. So if you want to calculate the total power in amplitude modulation, then we can write the total power PT. AC square by 2 we represented as PC. So you can write this PC, and AC square by 2 we can separate, which is PC. So now the formula will become PT is equal to PC 1 plus MA square divided by 2. So this is the total power. So this is very important formula where every time they ask the question, whenever they ask the question from the power, this formula will be definitely used. So this is how you calculate. Okay, so we have understood very basic thing that if any amplitude modulated signal is given, then the expression will be written in this form. So once we get the expression in this form, on comparing we get the different parameter like amplitude sensitivity, like a carrier amplitude, carrier frequency, message. And once we get all this, we can also calculate the modulation index. And extending our discussion for a single tone sinusoidal. So if I take my message signal, if I take my message signal as MT AM cos omega MT, then our expression will be this. Our expression will be this. And on the basis of this, we understood that actually in the amplitude modulation, we have a three type of signal. One is the carrier signal, second is the upper sideband, third is the lower sideband. Upper sideband are those terms which are having frequency less than carrier frequency, and upper signals are those terms which are having frequency higher than carrier frequency. Lower sidebands are terms which are having less than carrier frequency. And if I talk about amplitude modulation, that means whenever we talk about amplitude modulation, we will have three type of signals, which is commonly called double sideband full carrier. So amplitude modulation has the another name which is known as double sideband full carrier, because when we transmit AM, that is amplitude modulated signal, basically we transmit carrier and two sideband together, all the three components transmitted together, then we call it as amplitude modulation. And we can calculate the power also. If you want to transmit only carrier, then the power requirement is AC square by 2. If you want to transmit upper sideband, then the power requirement MA square AC square by 8. If you transmit lower sideband, the power is MA square AC square by 8. but in the amplitude modulation we transmit all the three components together. So to calculate the total power we have to add the power of all the three terms. So I added the power of AC square by 2 and these two. So when we added all these three, we get this formula. PT is equal to PC 1 plus MA square by 2. Clear? So in this way, we calculate the power. Now, there is a question for you all. Guys, if you solve this question, I become happier and also your confidence will build. This is the question from the gate 2024. Whatever you have listened in the last 60 minutes, you will be able to solve this question. An amplitude modulator has output S of t is equal to A cos 400 pi t plus B cos 360 pi t plus B cos 440 pi t. The carrier power normalized to 1 ohm resistance is 50 watt. Carrier power is 50 watt. The ratio of total sideband power to the total power. Total sideband power also we calculated. Total power we also calculated. The ratio is given as 1 divided by 9. 1 by 9. What is the value of B we want to calculate? Okay. Now, can you guys tell me which component is carrier and which component is upper sideband and which component is lower sideband? Are you able to identify? Here you can see there are three terms. There are three terms. Which one we call carrier and which one will be upper and which one will be lower? Anyone, guys? Come on. Okay, so this is center. As you can see, there are two different terms. This is our carrier because it is in the center, and this is 400, and this is less than 400, so this is lower sideband. This is higher than 400, so this is upper sideband. Okay, so the three terms are identified. 400 is carrier. Very good, Vinay. So Vinay has answered. And now 400 is carrier, 360 is lower sideband, 440 is upper sideband. Now carrier power is 50. So how do you calculate the carrier power? Carrier power, if I want to calculate mathematically from this expression, the equation which is given, what is the carrier power? I told you that if there is a cos written, then the amplitude square by 2 is carrier, right? So amplitude square divided by 2 is carrier power. Carrier power is given as 50. So equate it to 50. So what is the value of A? A square is 100. So A is 10 volt. A is 10 volt. Correct? So A we have got. Now the ratio of the total sideband power to the total power. So how do you calculate the total sideband power, guys? Total sideband power. We calculated just now. How do you calculate the total sideband power? We have to add the power of lower sideband and power of upper sideband. Correct? The power of lower sideband, power of upper sideband, both are having amplitude B. So this is B square. What is the total power? What is the total power? Total power is sum of all the three. Sum of carrier power, sum of sideband power. What is carrier power? Carrier power is A square by 2, which is 50. And what is sideband power? Sideband power is B square. So it is 50 plus B square. Correct? Yes, perfect, Vinay. B square by 2. B square by 2 also. Na? How means total sideband power you said B square, right? Now, what is our next step? The ratio of total sideband power to the total power. Sideband power we have calculated. Total power we have calculated. The ratio of both is 1 by 9. So, the ratio of B square upon 50 plus B square is 1 by 9. What we want to calculate? The value of B. In this equation, only one thing is unknown, which is B. So right, 9b square is equal to 50 plus b square. 8b square is equal to 50. So b is uh, 9b square 50. It will be 25 by 4 root over it. That means 5 by 2, that is equal to 2.5. So round off to the two decimal places, we are getting 2.50. 2.50. So right answer is 2.50. Are you getting how to solve? So see, this is the question that was asked in the gate. So can't you solve this type of question after attending our lectures? Are you getting the confidence? See, I told you each and every concept in very brief time. I mean, in 60 minutes only, I told you the concept and I show you the question also, that which type of question has been asked in the gate and how you are able to solve it. If you practice, see, this is only 60 minutes lecture you attended. Some of you are attending first time and still you are able to understand this. That means when you will practice more questions, you are definitely going to crack the game. Okay. So guys, you can contact in this number for more detail. You can share this lecture to all of your friends. Okay, it will be public in the YouTube also after some days. So you guys can share this with your friends. And you guys can suggest them to join us in our course, full course. So we all together prepare for the gate and we all together crack the gate examination. Okay. So more you share, knowledge will increase. Okay, sharing is always better than hiding. So whenever whatever you learn, share with your friends. If you are getting the good content, then share with your friends. Then you can, you both, your you all friends can prepare together, and it will be beneficial overall to all of you. So guys, thank you for attending this session, and we will meet in the next session, or maybe in the continuous session where we will dive into the deep concept of communication, where we will cover an entire syllabus of the gate. So thank you for watching again, and this is the number where you can call and you can share it with your friends, and this is our email ID and website. Thank you. Don't forget to subscribe our YouTube channel. You can search the IGC classes. That is India IITN Gate classes. You can search in the YouTube and subscribe the channel, because there we will be sharing some free sessions also, where you will get an idea that which kind of study environment you are going to get in this platform. Okay. Thank you. Thank you all. If you have
Yes,
any
sir.
query,
Thank you, sir. Thank you.
sorry, what you said, Shashidhar?
Sir?